Today we're going to be working on Leetcode question number 216, combination sum 3, part 3. Find all valid combinations of k numbers that sum up to n. So n is the sum and k is the total number of elements which we need to combine, such that the following conditions are true. Only numbers 1 through 9 are used. Each number is used at most once. Return a list of all possible valid combinations. The list must not contain the same combination twice. Okay, and the combinations may be returned in any order. So the example is k is equal to 3. We're going to be taking 3 different numbers. They can't be the same, and they need to be between 1 to 9. 1 through 9, and n, their combination should be equal to 7. Okay, we're going to be using the def for search for this one. Basically we have the result, which is empty at the beginning. Then we're going to call our helper function dfs, with basically we're going to initialize it to everything, like we're going to be initializing it to the total number of nums which we want to try from. So that is going to be the list, and the range is going to go from 1 through within less than, so 1 through 10, meaning like from 1 through 9, like, because the range is gonna stay within that. And then we have like total number of elements which we need in order to, which is gonna go in the that's gonna be the length of every single result. K, n is the total sum which we need. Then there is like uh, what is the current set of numbers we have already chosen. So the first one is uh, what are the different options. This one is what is the current result, and then the result, and in the n are the brackets. Okay, this is wrong. The list should have been just up to this point, and then we're going to be returning the result. Okay, now our DFS is taking the nums, the k, which is the total number of elements for every single solution, the n, the sum, the path, which is the current result, and the result. So basically the base condition is going to be, what if the k is less than 0, or meaning total number, like the elements which have been left with 0, or the n is less than 0, right? In that case, we're just gonna return, we know that there's no need for more depth first search recursion, because we're not gonna be able to reach to the solution. We're not taking negative numbers. And yeah, what if the k is equal to 0 and n is equal to 0? If the n is equal to 0 and at the same time the k has become equal to 0, that means that is our solution. Like, that definitely needs to go in the result. So we're gonna say the path, which is the running result, is gonna get appended to the result. And the last thing is, now we have to do the recursion for I in the range of length of nums. Self dot dfs nums. So now what we're gonna be doing is like we're gonna be saying that our nums is gonna be reduced, right? So we're gonna start from I plus 1, so on, like I plus 1. And so basically we're not just taking the I. So I is gonna start from 0 to 9. I'm gonna go from there. So we're gonna be starting from I plus 1 and so on. Every single time we're gonna be taking, the options are gonna be reduced. The second one is the k, which is basically gonna get reduced by 1. This is the number of elements which is gonna be part of the solution. Then the total sum is every single time uh, it's gonna be like the n minus the the nums of I. So we're gonna, whatever is the number pointed by our index I, we're gonna remove that number from the sum, and the path is gonna get added to nums of I, because we are taking the nums of I, and then the result is gonna stay the same. Okay, yeah, looking good so far. Yep. And it works.